What we're going to talk about specifically is a deep dive on the React Lifecycle, which is arguably one of the more confusing sides of how to actually use React. So it should be fun. So again, who am I? I'm Jonathan Creamer. This is my family, and we're Nashville, Tennessee residents. So had a nice long 12-hour day getting here Tuesday, but it was fine. I'm a senior front-end engineer at Lonely Planet right now. Lonely Planet is a travel company. Been doing travel guidebooks for the last like 50 years or so. And so I'm on the team that's kind of taking all that content and putting it on the web, inspiring you guys to travel and all the people around the world. It's really fun. I used to work at Append2. It's a fun company with Elijah Manor, a couple other amazing developers. So, all right, let's get this thing started. So here's what I kind of want to talk about today. First of all, I want to just talk about, and I actually want to quickly poll the room because I like doing this. How many people like use React in production right now? Okay, so a lot of people. So how many people are like iffy on the lifecycle method? That's kind of the thing that has always, yeah, okay, good. So I've seen a lot of hands raised in there. Good to know. So I want to talk about just really briefly what a React component is. Sounds weird, and why we need the lifecycle methods. Talk about some use cases. I've got some actual kind of example code that we use in production at Lonely Planet for this stuff. And then finally, you may or may not know that you can actually unit test the lifecycle methods with this awesome tool from Airbnb, so we'll talk about that a little bit as well. So the first thing I want to talk about is this idea of a pure function. It's a concept that's been around for a really long time, and it's tossed around a lot because of how React components can be a pure function. So basically, the Wikipedia definition is, given the same input, returns the same output, no side effects, and relies on no external state to be mutated. So essentially, whatever you pass into the function, no matter how many times you pass it in, it'll always return the same thing. Nothing's going to happen when you fire this function other than what you expect. And then third is you can't mutate any of your arguments that you pass in. So if you pass in an array, don't do like array.push, or don't mutate the object, return a new, mess with it, but don't actually, change it in any way. That's kind of the general idea. And so one way to build React components is by building pure functions, right? And you've probably all seen this kind of stuff, but it's really nice. I mean, how cool is it that you can build, an entire tree of elements with just functions? So you obviously you can get your props destructured at the top here, and you return some sort of element, and then render it with React DOM, passing your props. Sometimes this might be all you need. It's nice and simple. Your state of your application would get elevated to other components in this case. But a lot of times, you need more than this. This, of course, compiles down to JavaScript, which a lot of people, I remember when I first saw React, I was like, what is this crazy HTML-looking stuff inside my JavaScript? And I remember being like, Facebook, you guys are crazy. What are you talking about? So finally got over it and love React now a whole lot. You got to use lowercase names for built-ins and capitalized names for custom elements. You guys probably know a lot of that. So we'd have a really boring application if you just use these pure functions because there'd be no way to interact with the application. So that's why you can build a React component as a class, right? So you extend this React.component, which is an abstract base class, which means you're not going to create a new React.component. You're going to extend React.component onto something else. That's what an abstract class is. And as long as you have a render function, you'll get props off of the this. And you want to make sure that you're not messing with those props. They're read-only. And also, don't jack with any state in your render method. So if this is all your class looks like, there's actually no reason why you wouldn't just use a functional component, pure function. And even like the Airbnb JavaScript coding style guide will tell you to not create a class like this. They would say use a function because it's easier and cleaner. But a lot of times you need state. So we'll talk about why and how to interact with that. So the lifecycle methods are broken down into 3 different categories. So the first one is mounting, and there's 4 for mounting. You've got your constructor, your WillMount, your render, and your DidMount. Then you've got updating, which is a will receive, should component, will update, render, and did update. And then the last one is the unmount. Okay? So we'll kind of go through each one of these, talk about them for a second, and show a little bit about them. So the first one is the constructor, which is something that's built into ES6 classes, But React and the Facebook team was smart enough to use that as kind of your first lifecycle hook, even though that's kind of built in. So React.component has its own constructor that you can override, and that's why you have to call that super props thing. If you don't call that, you're going to have bugs in your constructor because React's not going to get the props set right. So you always have to remember to call that first. That's another thing that if you're using ESLint and you've got it set up right, you should get a warning about that because otherwise you're going to have bugs in your code. So don't forget to call super props. And it's in this lifecycle method, just like with any other class, that you would perform just initial setup for your class. If you have to set up your initial state in here, which you can set up as just an object with keys and values, however you want to set it up. You have to do this, though, if you're going to work with any state. Yeah, and this thing gets called once per mount. So this constructor is only ever called once. And you can also bind function handlers in here. There's a lot of cool things you can do inside the constructor. So I use the word state a lot, and I like to just put definition around what state actually means, because it's just kind of one of these words you hear thrown around a lot. So I like to think of state as what's going on around here now. Has the user clicked or typed in anything? Is there any data that needs to be fetched? Anything like this? And so you use state in React by calling setState. Probably everybody's done that. And a lot of things happen when you call setState. So let's just say we're going to build some kind of WYSIWYG component. First thing I'm going to do is pull text off of my state. So that implies that I would have set it up in the constructor. In this case, I'm going to have an onChange that calls this.update and pass down that text as a value. So in the constructor, I will have had to have set up that text in my initial state to make sure it's there. And then another really important thing is to make sure that you have the correct context for your function. Because anytime you pass around a function like that, of course, JavaScript's this is really screwy. So the this.update here is set on the prototype of the class. So what we're going to actually do is create an instance property called update that binds it correctly to the right this. So that way you can call this.setState in your update, and it's going to be the correct this that you think it is. So in this case, I would be basically grabbing the E, which is the built-in event from a synthetic event from React, and I can set the state based on text. So as soon as I call setState, our render's going to fire. So it's important to remember, though, that you have to call setState in order to update your state. You can't just say this.state equals text, or excuse me, this.state.text equals foo. You can't do that. You have to call this.setState. Another important pro tip about setState is that it is actually asynchronous. So if you're actually trying to compute state based on some other previous value, you can't just say this.state.count plus your props. That will potentially have a race condition where your props aren't set exactly right, and you can run into some bugs. So if you're trying to rely on some previous state, you have to pass setState a function, and you get the previous state, and you can pull the previous state.count plus your new prop. So just a nice little tidbit of information. So that's using the constructor and calling setState. So the next lifecycle method I want to talk about is component WillMount. And so I put an AKA next to some of these things because one of the weird things I think about the lifecycle methods is just the names. When I first got into it, I was like, what do all these actually mean? So I tried to kind of think about them more holistically, like what is this actually, how do I actually use this? So I think for the constructor, I don't know if I put it on there, but I usually think of the constructor as like my initialize. So my WillMount, I think of as like a before DOM ready, because at this point, the props and state both are ready to mess with in component WillMount. You can call setState, but this one is one of those ones that's in there. I don't use it all too much. I think even in the docs, they say like most of the time just use the constructor to set up things. So it's worth knowing that it's there. You can use it to do some extra because the props and state are there, but most of the time just use the constructor. It's just a lot easier. But I want to make sure you know that it's there. So the next one, and this one is one of the most important ones I think, is the DidMount, or I like to say AKA DOM ready. You're like jQuery ready. And the reason I say that is because a lot of the time that you use DidMount, you're going to be manipulating the DOM at this point. You can set up your jQuery plugins if you want to do that inside React, which is just a really fun thing to say. The DOM is actually ready here. The component has mounted itself against some element. So you can stand up any plugins. I mean, it's just be real. You know, there are a lot of React-star plugins on NPM, which is ideal, but there will still be cases where some legacy application just doesn't have a React wrapper yet. So this is your opportunity to go in and play with the DOM. You can dispatch actions from in here. So if you're trying to fetch any data, anything like this, this is a great opportunity to do that. So let's look at kind of an example. Let's just say for some reason I wanted to make an editor that pulled in like Ace editor, and say there was no React-Ace plugin for React. So this is where I would do that. I would pull in Ace from Ace editor. The first thing I would do down here, I don't know if this changed a little while ago. Now ref has to have a function passed to it. You used to be able to just like name elements with ref. You can't do that anymore. You have to pass this function, which gives you a callback for the node, and then you can set up a this dot whatever on your on the instance of your component. So that refers to the actual div here. So then in my DidMount, the DOM has run, so I can actually pass it down. So this is how this works. The constructor fires when this component is getting initialized. You set up your initial state, and then your render fires. You get the ref set up for your this.$text, and then your DidMount fires. And it's good to, like, anytime you're going to create some sort of, if it's going to return you something, you want to set like an instance property on it. Because as I'll show in a minute here, you want to prevent memory leaks in case this component gets destroyed, which leads me directly into the component WillUnmount, or AKA destroy. So this one is really important if you're doing anything like what I just described, or if you're doing some kind of event binding or pub sub or anything like this, because the way that garbage collection in JavaScript works is if I have a DOM element and I apply event handlers to it or any kind of data on it, even if I remove that element from the DOM, because there's some sort of binding against that element, it's actually going to stay in your memory, and you're going to have memory leaks. Especially if you're working in an application with like React Router, where you're constantly moving around and things are getting removed and recreated and added to the DOM. It's extremely important to use this unmount lifecycle to make sure you clean up after yourself. It's the same thing we used to do with jQuery, where you would do $on, and then at the end of something you would do $off. And that's why, because you can literally go into the memory profiler in Chrome and see that some DOM element that you thought you had called .remove on is still there because you had some event handlers on it. So you got to make sure to do that, because that can actually really hit you hard, especially if you like added event listeners to like a big list and you have all these things that you removed and thought they were gone, but they're not. So clean up, be a good citizen. So this is how the unmount flow would look. So let's say for a minute that I have an initial state set up with some messages on it. And in my DidMount, what I'm going to do is set up, has anybody used Postal? It's a fantastic pub sub library. A friend of mine, Jim, wrote it. It's based on the AMQP message style. So let's say that I set up a Postal subscription. I'm going to listen for messages that have a topic of message.added. And anytime that that message gets posted, I'm going to set a callback that creates a new array on my state, and then down here in my render, I'm going to pass along the message to the messages component. Okay? I guess I kind of did that, but yeah. So the first thing that's going to happen again is the constructor. Then your render is going to fire, and then your DidMount is going to fire and set up that subscription, and then your component WillUnmount will fire, and you want to make sure to call this.subscription.unsubscribe in the case of something like Postal. So again, this is just that idea that you've got to make sure you clean up, because that garbage collector is not going to be very friendly to you if you've not cleaned up your stuff. So be a good citizen. So kind of want to talk about some in real life examples of how some of this looks. So this is an example of our list page at Lonely Planet. So let's say that we're browsing through a list of restaurants, and you click on one of these. So I'll kind of talk about what that looks like here. And I can pull up San Francisco restaurants so you can see this. Here we go. So the way that we do this on Lonely Planet is this page is server-side rendered. So you can actually go in and view the source. It's rendered with Express. The HTML gets delivered down. What's really cool is as I'm browsing through this stuff, for one thing, once I get to the bottom of a list, it's infinitely scrolling, and that's all making AJAX requests and fetching new data and re-rendering new components on the client. So we get to reuse those components. It's fantastic. Server-side rendering is an amazing piece of why I love React so much. And then now what happens is, let's say I want to check out La Taqueria. I click here, and that was actually all client-side rendered still. Even though it looked like a page refresh happened, I jumped up to the top. That was all actually client-side rendered. So I was really excited to be able to build this product. It's really fun to architect in this way. And I'm hoping to even take this even further and do like a dynamic single-page application across our whole site, but that's down the road. But yeah, these lifecycle methods have allowed me to do that. And let's pull this back over here. And this is what kind of it would look like in the case of doing something like that. So what we do is we use Redux, first and foremost, for everything, for managing our state. And then what I would do is, at first, my list component would mount and be in the DOM, and it would render all my list of elements. But then when I jump over and render a POI detail page, a POI is a point of interest for us, I would not have a POI yet in my memory because I was just on that list page. So what I want to do is I'm going to pull a POI off of my props that would get passed in through Redux. And there isn't one yet, so I'm going to say if there is not a POI in my props, then I'm going to fetch an action, and I'm going to pass along the props.params.id that I get from the URL. So that's literally in production how we are fetching our AJAX requests, and it's really nice, really clean. And then same thing here. If I have like a list of related ones down at the bottom, I do the same thing. If I don't have them, let's go fetch them. But it's really cool because if you go to one of those POI pages and hit refresh, it's server-side rendered, and so my initial state does exist. So the POI would be there. So this doesn't fetch an AJAX request when you go to the page when it's server-side rendered. So this is a really powerful way of giving your users feedback as soon as they hit a page. That server-side rendering is really powerful, and it's not that hard to add. It took a little while to kind of wrap my mind around what it meant and all the different nuances of getting it right. But yeah, our users love it, and they get that feedback quick that Google expects for better SEO and all that fun stuff. And React Router is amazing as well. Let me jump over back to here. Cool. So the next lifecycle method I want to talk about is this component will receive props. And I like to think of this one as like an on-change, kind of more or less. And it's really important to remember your elementary school grammar here because I before E, except after C is really important. If you go search on GitHub for a component will receive IE props, apparently 3,000 poor souls have misspelled that. And I believe actually React has started throwing a warning if you do this, so hopefully it won't be a problem. But I remember when I first started doing this, I'm like, why is this not firing? And I'm like, oh God, grammar sucks. So the component will receive props method fires whenever the props that get passed down into that component change in some way. So it's not called when the component first stands up. It's only called when a parent-child relationship happens and the parent passes different props down to the child. And so you use the will receive props method as a place to kind of react to your props changes and update some kind of state. And you can also dispatch actions in here. You can call set state. You got to be kind of careful with how you do your checks in your will receive props, and I'll talk about this in just a second. But I've run into many having to force quit Chromes because I created an infinite loop in this method. You got to be real careful. It's really useful for the single page application use case that I'll show in a minute. But the first example I want to talk about, and this actually is a component that we built that lives in our style guide. We're working on a new style guide for Lonely Planet's ecosystem. We used to have one called Rizzo, and now we're working on a new one called Backpack, and it's just full of React components that we use all over our site. Most of them are the pure function ones, but there's some like this avatar uploader that we're going to use for our new profile that needed its own state, because the idea was you'd have like this little profile, and you click browse and choose an image, and we wanted to be able to basically populate that image with the new one you just uploaded, and also fire an action for the parent component. So what we do is in our constructor, we're going to set up initial state. We're going to set up our initial state with a prop. And so this is something that even in the React docs, they say to be really careful about, because this can be an anti-pattern if you're not careful. And the reason is because if you're setting up your state based on a prop that gets passed in, you can get out of sync with that prop. So the way you get around fixing this problem is by using the will receive props hook. So if for some reason the prop.source gets changed from the parent down to the child, I will get this component will receive props update. And then I can go in and say, my next props.source, is it the same or different than the one I currently have? And if it is different, then I'm going to update my state. So that's how you avoid that anti-pattern of breaking your state. So you got to be real careful with this, but it's a really nice way to be able to have your own version, like forking the state, I think is how they describe it in the React docs. So again, just be careful when you're doing that. Watch out for it. There's a nice little blog post I have linked in here. Oh, and by the way, I forgot to mention this, but in the bottom left corner is a link to the slides if you want to get them. It's bit.ly/react-lifecycle. I know it's really small, but feel free to check those out. And I'm jQuery down there. Anyway, just popped into my head. So yeah, this would be an example of where, like, say I have some editor component that's using my avatar uploader. This action perhaps might change the image, and when I pass that down in here, this parent component, since it's passing those props down, that action would fire that component will receive props inside my avatar uploader, so I got to keep my state up to date, pulling that state off of Redux. So that's a really good use case for that. So another really good use case for this will receive props. So back on that detail page I was showing you of the POI, let's just say somewhere in the body of that detail page I have a link, a React router link to like the Country Music Hall of Fame. That's where we're from in Nashville. So what's going to happen there, the link component from React Router, what it does is it overrides it uses the push state, HTML5 push state, changes your URL, and so it looks like you're actually navigating, but it's not a real navigate, it's just this, this push state thing. And so if the component is already mounted, what we're going to do is we're going to use that will receive props hook because React Router passes down all of your routing parameters as props to your components. So what we're going to do is we're going to examine the next props and the current props, and we're going to say, all right, so if in my route I have an ID in there, I want to say, is the next ID coming down different than the one that I have right now? So I'm basically going from the Ryman Auditorium's ID to now the Country Music Hall of Fame's ID. So since those have changed, this is an opportunity for me to say, all right, cool, well, I guess I need to go fetch the Country Music Hall of Fame now, to go get that AJAX. So that's what's going to happen is I'll be able to dispatch that action, pass that ID along. And a couple interesting things you may have noticed. This is like a really weird new JavaScript thing you can do. This is destructuring, but you can actually alias it to a different variable. So anytime you're messing with component will receive props, it's really nice to do something like this. That way your if statements are nice and clean. It looks a lot better than having this.props.params.id does not equal next props.params.props.id. And anytime you're doing any kind of those checks, it's really good to just be verbose in your variable naming. So that way when you come back to this thing, you can remember why the hell you compared one thing against another. Because I've done this a few times, and then I come back and have a bug, and I'm like, oh my God, what is happening in here? So yeah, just be really explicit in your naming to help you and your team remember why you are comparing the things you're comparing. So what I talked about a minute ago with the component will receive props being slightly dangerous if you're not careful, I've done this a couple times, both of these examples a couple times. So I would accidentally grab the ID out of the URL and compare it against the next props.poi. Well, technically, I'm never going to have fetched the POI at this point, so this is always going to be true. So this will loop over and over and over and over and over and over again right there. So that's not a good thing. And then another example that I've done many times, and this one is especially dangerous when you're using Redux, because if you've ever used Redux, you know that the props pretty much are always different because you're always returning a new object. So you have to be really careful comparing an object against an object because they will never be equal because Redux compares by a shallow compare and not by deeply comparing the props or deeply comparing the keys and all that. So make sure that you use a .id or a .name or something to check in that way. So nice little pro tip. You don't want to get yourself in an infinite loop. It's not very fun to deal with. The next one I want to talk about is this should component update. And this one I like to think about as a should render. So you can actually use this little guy to decide whether or not you want to actually continue and render your component based on some sort of props or state change. And this is a really good one that you can use if you're running into some performance issues. If you have like a long list of things or some really large component. It used to be the case, and I'm just kind of telling you where we came from with this, where by default the should component update will compare like deeply nested object comparison for calling set state to determine if it should re-render. And that's expensive. That deep comparison can be really heavy depending on what your state looks like. So React had this function called shallow compare, which forces it to just check, do these objects shallowly equal each other? Like, is this object in reference equal this other object in reference? So that can save you some re-renders and some repaints in your DOM. Thankfully, though, now React has this thing called a pure component. So rather than extending React.component, you can extend React.pureComponent, which basically under the covers implements this shallow compare function. However, you may just still want to get, there's still maybe some sort of thing that you're like, I just really, really want to do this myself. So you still can override should component update, and you could say like, does my next ID not equal the current ID? And in this case, this would work. And so basically I'm saying the only time I want to actually re-render this component is when my POI IDs are different. I don't want to, I don't care if any other props change except for that piece right there. Because returning false will cancel the next three things that we're going to talk about. The component will update and the render and the did update. Those will not fire if you return false here. Okay? So the next one I want to talk about is component will update. This is like kind of like a before render, if you want to think of it like that. It's not something I use very often. You cannot call set state in here. Do not do that. It will break spectacularly. A lot of times causing more infinite loops. So don't do that. Honestly, I really haven't even used it all that much, but I know I've seen that you can do like CSS transitions in it, different things like this. So it's another one that's worth mentioning, but not one that I'm commonly using all that much, but it's good to know that it's in there. Then you have the did update. Now this one's kind of like an after render. So in this case, you get access to the previous props. And so what I'll use this one for, and we use it in production, is to so this is where I was saying, if I have a detail page and I click a link that I want that component to re-render, I use this as an opportunity, if I've scrolled down, to jump back up to the top of the page to make it look like I've actually left. Or also, we'll use it to fire a page view. That's one thing that you don't really, it was so frustrating when I was working on this stuff. Like, how do I actually fire like a Google Analytics page view? Because I'm firing actions all over the place, and I don't know when that data's ready for me to because you got to update the meta title and all this stuff. So this was a pretty good way, I believe, that we ended up settling on, just basically telling Google Analytics, okay, cool, we've got a new POI in the DOM, so now you can fire a page view for our lovely analytics team. So that's a kind of nice example of where you can use that. And you can use it as an opportunity to work on the DOM too, after a render, if there's any other weird things you need to do. So, all right, let's go through like a full example of one of these things and what it looks like. So this is it's a stripped down version of our actual kind of POI detail page that we have in production. So in review, the first thing that's going to happen is we're going to come into our constructor. We're going to get some props passed down. We've got to call super. We can set up our initial state. And then we're going to jump down and do our rendering. Then we're going to be able to come up here and do a DidMount, set up any kind of subscriptions we need. We're going to, let's just say, for an example, that we have this a link down here in our render. So these props will get passed down. So let's say that I click on that link because I want to go navigate now to a new POI. The component will receive props will fire. And this is my opportunity to say, okay, has the ID in my URL changed? And sure enough, it has. So I'm going to fire an action from Redux and pass along that ID. And now here, this is interesting because this is what I was saying a minute ago. The params prop has changed, but my POI hasn't. So I'm actually just going to stop the component from re-rendering in this particular case. I don't really care if it re-renders when my IDs change because it wouldn't change anything. So I'm just going to nuke it and say I don't need to render here. because that ID hasn't changed. And then we're going to wait for our AJAX request to fire. And then once that AJAX request fires, Redux will be nice and pass me my new POI. And in this case, since the IDs are going to be the same, so it's not going to refetch a POI, thankfully. And then we're going to go down to our should component update. Now in this case, I do have a new POI. The POI that came in from next props is going to be different than the one that I have. So we're going to go down here and we're going to do our will update. You can do any kind of prep for your rendering. We're going to go down, render the POI, and then you can call the did update and make sure, again, that you're checking the right thing. You always have to have these checks, and I can reload or jump at the top of the page. So there you go. That's like a full kind of real-life running example of how you would use all of the lifecycle methods in one fell swoop. So kind of the TLDR, I have some visual guides to help if you ever want to take these and share them at work or just kind of keep them next to your desk. I put together this is a gist on GitHub, but I copied it in. This is a Markdown-based editor, so I was able to copy it in. So I've got all the different lifecycle methods in a column here, and kind of their little easier readable names. So constructor is initialized before DOM ready. So hopefully this will help. I just kind of put a little whether or not it's actually mounted in the DOM at this point. You can actually only call set state in certain ones, so I use this to kind of have a guide as to which ones you can call set state in. And then there's just kind of a really brief, sort of goofy one-liner about how to actually use this thing. So again, I've got a link to this in the end of this slide deck as well, so you can have that gist. I found this actually by code splunking React. It's kind of cool. Inside their code, they have this nice big long comment that shows you the whole cycle and all the different things that happen in through here. So that's another nice little one. And then if you're a very visual person, this is a nice guide. It has some of the older ones that we don't really use much anymore. Before they used ES6 classes for creating React elements, it used to say react.create class. And you still can do this, but you're going to get a deprecation warning as of like 15.6, I think. So that default props and just get initial state aren't really applicable anymore. But you can see how it goes through all the different, it goes component WillMount, render, DidMount, and then you're kind of hanging out around here. You've got your Unmount that goes this way. If you call set state, it goes down and does this and this and this and this. This shows you which ones you can call set state in. So this came out a while ago, Tyler McGinnis. So that's a nice visual guide as well. So it depends on kind of how you like to view things. So there's 3 different ways you can help remember these things. So the last thing I want to talk about is how you can actually test this stuff. Because I break things a lot, and unit tests help me not do that. So I hope you do testing, and if not, let's get you started on it. How many people use Jest already? About half the room. That's great. And Mocha, same thing, or just unit testing in general, I guess, is a good question. All right, good. So if you aren't doing unit testing on React components, I would highly advocate you to start, because the fine folks, Leland, Richardson, and et al. At Airbnb, once again, have put together an amazing library for us called Enzyme. And Enzyme is a renderer for React components in unit tests. It does a shallow render, so it won't go down the DOM tree like really, really far. It just does like a nice little shallow render so that you can check against things. And then Jest has some really amazing tools for rendering React components as well. You can call this thing called toSnapshot, which is really amazing. You can render a React component and call you expect.toMatch snapshot, and it'll actually render your React component to a string and store it alongside your tests. And so you can actually go in there and make sure that the component rendered exactly as you expect. So there's really like almost no reason anymore to not unit test these things, especially if you have any kind of logic in them, especially with all these lifecycle methods. It's really simple to run. Then the other thing that Enzyme has built in is it exposes not only a shallow render, but also a mount function. And what the mount function does is under the covers, it uses JS DOM, and it will actually like mount your component inside like a fake DOM in Node, so that way you can actually test some of these lifecycle methods. So for example, let's say that I'm writing a unit test for my detail page. That's one of our most important pages on our site. We get like millions of views on this stuff, so I want to make sure that if somebody clicks on a POI or they go to that page, that our JSON is actually getting fetched and the right methods are getting called. So what we're going to do here is we're going to describe a detail page, and we're going to say it should fetch a page if one is not already loaded. So this is the case in which I'm going to go basically from the list page to a detail page. All right, so this is kind of what I'm testing in this case. So the first thing I'm going to do is create a jest mock. So we're going to say fetch equals jest.fn. Really nice mocking or stubbing piece from jest. And then what we're going to do is we're going to call this mount. And this is, you import this out of Enzyme. And when we mount, we're going to pass our JSX in here. And initially, our POI is going to be null. So this is the case, again, when you're kind of jumping from one page to another. And then we're going to pass this fetch POI in. With Redux, you can do the map props to dispatch. And I do that a lot so that I can test that to make sure that when these lifecycle methods fire, that some prop is getting fired as a result. So when you saw earlier in my DidMount, I would say like, if not this.props.poi, it'll call that POI fetch. So I expect when this thing mounts that my fetch has been called. So this is how you use jest to say expect this mock to have been called. That's the API for that. So everything's hopefully green in this case, and we can be happy and assured that if there wasn't a POI that we're going to go fetch one. And no actual like XHRs are happening in this. It's just making sure that the browser's going to, or React's going to call the right stuff when this thing mounts. So that's how you would test like a component did mount. And then for like a will receive props, that thing can get pretty ugly and pretty hairy. We've had some tough times making sure that we have the right cases, like I said, breaking with loops and everything. So that one's really important, I think, to make sure that you're testing. So once again, I'm going to call jest.fn, create myself a stub. I'm going to mount it, but in this case, I'm going to assume that I actually already have a POI rendered, and then I have the ID from the URL with this params, and then I'm going to again pass my mock. So now what you can do is the mount function returns you this like wrapper around your component, which gives you some nice methods. You can actually do like jQuery-like things too, and go like wrapper.find element and test things like this. But one of the nice ones you can do is you can actually call .setProps. So in this case, I'm kind of testing the idea that I've clicked a link in my POI detail page, and I'm re-rendering it to a new POI. So in this case, setProps is going to fire my will receive props for me so that I can test to make sure that when my will receive props fires, that I'm fetching a brand new POI. So again, this is really, really easy to do. I mean, there's not much code here. I can't stress enough how important it is to you and your team to try to work this in here. It's really fun. Jest is great. You'll love it. So here's kind of some additional resources. Again, that gist of that table is this first link. There's different things here you guys can check out by downloading the slides. And that is all I have for you this morning. So thank you very much.